Ken, we've been talking a lot about the L-carnitine and the uses and so on, but I know that Sigma Tau has been very, very active in research, supporting research, sponsoring it and so on. And perhaps we can talk a little bit about some of the research that is been recently released on one of the forms, that is the glycine propionyl L-carnitine.
Sure. We have an ongoing effort with the aminocarnitines for trying to get a better understanding as to how these products offer the support that they do. Our first study that's been completed and it started about 4 years ago, and that we found that, amongst other things, that there was a increase with the glycine propionyl carnitine, an increase in the ability for the cell to retain nitric oxide. Now, nitric oxide is a very highly precious signaling molecule. It's a gas in itself, but it's a signaling molecule, and it's kind of responsible in part for flipping that switch that allows the blood vessels to relax after strenuous exercise, so that blood flow can be facilitated into the muscle and therefore to create the recovery. Now, here again, it's a matter of argument when we talk about what the exercise is. I mean, essentially, you know that when you eat a heavy meal, that's an exercise. Your heart rate goes up. I mean, you're speeding up your metabolism. I mean, this is an exercise. When you take a walk, when you run, when you shovel snow, these are all exercises. And unfortunately, in some extent, these exercises occur at a time when people are least able to handle it. So in other words, the combination of two of these exercises together is reason why you can see why sometimes people have fatal accidents, because they've combined two exercises. In other words, eating a big meal and then going out and saying, I'm going to shovel the walk. It's not a good idea if you're a particular, it could be a point where your demand for oxygen is more than your body can handle, and this is the cause for severe cardiac accidents. Well, this is why things like glycocarn can add additional support and create the blood flow necessary. That could be one thing about carnitine in general, and that is that it's implicated in so many different support situations that people start scratching their heads saying, gee, is there anything that this stuff isn't good for? When we talk about aging and anti-aging, we're talking about anti-aging at the cellular level. All the stuff that we've been discussing here about the way the cell works, about fats being an important nutrient to the cell for a source of energy, but that when you burn that fat, it creates end products that can be less than desirable. Well, carnitine helps to get those waste products out. Those waste products, if they remain in the cell, clog the cell membrane. The cell membrane is unable to carry on its normal cell functions, and so over a period of time, the cell wall gets kind of brittle, and the cell dies. Okay, fine. We've got billions of cells. A new one comes in to take its place. Unfortunately, there's just so many generations of replenished cells that the body can do before it starts saying, you know what, I think I'm coming down with something. I don't think I can do it anymore. And so that particular organ or that particular system starts to behave somewhat erratically. And at that point, unless you step in and do something to intervene, you're talking about a situation where you're supporting health, maintaining wellness, or not. And so because carnitine is so involved in each of our body cells, and how do we know this? Very simple. Whatever a cell has a mitochondria, carnitine has got to be there. And so what does that mean? Well, most of our body cells, they have lots and lots of mitochondria. But different types of cells have different levels of mitochondria. If you think in terms of where is carnitine needed most, just go over and count the mitochondria in that particular cell. In some of the major muscles, there may be 250 to 400 mitochondria in each of the muscle cells. But in a nerve cell in the eye, there may be 11 to 1,500 mitochondria per cell. So that gives you a clue as to how important fat is for that particular type of cell. And that also shows you where it's most needed. I mean, essentially, the heart has a tremendous amount of mitochondria as opposed to other muscles. So that's a tip-off that fat is a crucial energy source to the heart. So people get this idea that fat is not good for them. Not true. Fat is crucial. It's necessary for nerve tissue, for heart tissue. It's just a matter of the way it's utilized, and like anything else, too much of a good thing is no good for you.